Hello, everyone, and a warm welcome to each and every one of you. I'm super excited for this session on generative AI. So let me go ahead and quickly introduce myself. My name is Afshan, and I'm currently working with an Israeli firm as an OSINT analyst. And I am also working as a part-time instructor at Securzy.io. And, if you haven't been aware of the recent buzzword around generative AI, you must have been completely out of touch for at least the last 6 months, the past 6 months. This topic has gained immense attention, extending, beyond the realm of data scientist or data analyst. Even my relatives are talking about this particular topic. My family is talking about this, generative AI. So this presentation aims to serve as a comprehensive guides for builder interested in generative AI. Okay, so to ensure we are all on the same page, let's examine a few quick examples of generative AI. Okay, so these images you see have been generated using text to image model by inputting text like a dog wearing sunglasses and a hat, or a dog wearing glasses and a hat. The model creates unique images that have never seen before. And additionally, we have all encounters, chatbots, and text-based generative AI system that can provide, meaningful answer to our question. And these technologies are truly remarkable. And in this presentation, we will delve into the underlying technology behind these tools. Okay, so here's the quick definition of generative AI. Generative AI is a branch of AI, that is artificial intelligence, that focuses on creating new data, and it is a subset of machine learning. So let's take a quick look at the agenda of this presentation. Okay. First and foremost, we are going to dive into the fascinating journey towards the generative AI. And we have been on this path for quite a while. So let's explore how we have reached where we are today. Next up, we'll chat about language models and uncover how they actually work. Then we will delve into text to image models and get a feel for how these clever models bring those images to life. And we will also touch upon the exciting field of prompt engineering, which is something us as a builder needs to wrap our head around, because it's going to play a significant role in our futures. And lastly, we will talk on what lies ahead, which may seem a bit audacious considering how rapidly things evolve in this field, but we'll give it a shot. So let's kick off our discussion with the road to generative AI. And this is a journey that we have been, embarked on for quite some time. Throughout history, we have been constantly creating language, content, and various documents as a society, right? While all of this information has been written down, and there have always been individuals among us who strive to decipher the inner working of the languages, right? So they seek to understand the relationship between the words within the documents we produce. And that's where we begin the concept called word embeddings. We have a representation of words, or a special way of showing all the words in our language. And when we achieve that, we create something called a language models. Okay, basically a language model is a way to represent words and how they relate to each other's using vectors. We achieve this by using different techniques. In the past, one popular technique was called word to vec, or word to vector, which involved different algorithms that could take all your documents and produce sets of words embedding or vectors. We use these words embedding for various tasks in natural processing language, or sorry, natural language processing, or NLP. Imagine we have a sentence, but we can only see the very last word, which in this case is lazy. Okay, using a simple word embedding technique, we can find the word that is closest to lazy. Okay, in the context of the sentence, maybe it could be a person, right? A lazy person. That could make sense and complete the sentence, right? But it's quite likely that this might not be the word we actually want, because we can't see the rest of the sentence, right? We can't see the rest of the sentence. So how can we do better than this, right? So let's move towards the technique that used today. The next step after the simple word embedding lookup is to use something called recurrent neural networks, or RNN. RNNs can consider not just the last word, but also the last few words in the sentence. For example, if we see, fox jumps over the lazy, right? So we are looking for the next word, right? Here, in this case, the person is not the answer. Although, the we humans are very great and we have brilliant mind, so we can predict the next word accurately. But put yourself in the shoes of an RNN, okay, the recurrent neural network. It has, generated, rabbit, okay, because this is because RNN requires a lot of computational power, and the more words we add to the context, the more resource it need to predict the next word. Okay, remember it. RNN requires a lot of computational power. Let's see some of the application for generative AI. Okay, the very first thing, text generation. There are many types of text generation. It is a versatile application of generative AI, and we also use game design, industrial design. Generative AI has been used to generate different characters and elements for a game. Another exciting area is a drug design research. Next, we have image generation. Uh, Generative AI can be used for image generation. You can provide a text prompt, and the AI can generate an image based on that prompt. So the ability to create visuals from text is quite remarkable. First, we have a language model. As you guys can see, we have word embeddings. Images, we can generate images based on the text input that we provide. So one example of such model is stable diffusion. Okay. Stable diffusion, in a simpler term, we can take the concept of, representing language and, images using embeddings. And when we bring them together in an application, we can generate images from text. It's like turning a word into a picture. So let's explore the example of how we can use prompt engineering in a language-based setting. Uh, okay. Imagine we are creating an application that uses generative AI to write blog post for us, okay, which is probably happening already. We are using ChatGPT, right? So in this simple app, we can input a title of the blog, okay, title of the blog, and maybe specify the desired length, okay, desired length of this blog. Although this example is a brief, in reality, we would gather more information, right? We all have already using ChatGPT. And now what happened behind the scene is, when we want to use a generative AI algorithm to create a blog post, we take all the collected information, okay, about the blog and compile it into a prompt. A prompt is, it's simply a text string that conveys what we want to happen. So here it's essential to note that the prompt is often much longer than the user provide information alone. We have seen that, how to win a tic-tac-toe, and we have already seen how to write the XSS blog, in chat gpt, we know it, and the response of that particular prompt will be long, right? Chat gpt answered it in a very great and human readable format. Thank you, everyone. Have a wonderful week. Bye bye. Take care.